This is question 4 from the problem set on the topic of consumer theory. Let's solve this question and demonstrate the application of consumer theory concepts on leisure and labor trade-off. So let's say we have 24 hours per day. A says, draw your budget constraint assuming that you pay no taxes on your income. So basically, within that 24 hours, you can either have a leisure time or a work time, let's say. It's a very simplified assumption. So here on the x-axis, let's put leisure time. Let's say this is in hours. And on the y-axis, because we work, we earn income, which enables us to have consumption. Yeah, so let's put consumption. This is the usual sort of variable in labor-leisure trade-off analysis. You can put income if you want, but consumption appears to be the common sort of variable in these examples. So consumption includes basically the food or any services that we consume during a day, let's say. And we know that if we spend all of our time, that will be 24 hours of leisure time. So if you don't work, that will be the amount of leisure you can enjoy. If you don't have leisure time and spend all of our time working, then we will have some amount of income, yeah, that we can earn using 24-hour time that we are given. So that would be, let's say, this point. This is the maximum income, and for which the maximum consumption as well, yeah, that we can enjoy at this point here. So if I connect these 2 points now, yeah, that's better. This line basically is our budget constraint 1, and we know that I can afford anything along the line or inside this triangle. Yeah, so I can any point inside this triangle is attainable for me, and that's when we have no taxes given before tax income. This is what I could, what my budget constraint could look like. Now, next, on the same diagram, draw another budget constraint assuming that you pay 15% income tax. So with that 15% income tax, let's say my original income was £100, and I'm just picking as an example. And my second after-tax income, which is our now disposable income, is now 100 times 0.15. or 85 basically. Yeah, so that is the amount of disposable income I will have after tax. So that's £85. So my income basically declined by £15 from that amount to this amount. What happens now is that my maximum amount of consumption will now decrease, yeah, because my real income has got decreased. So let's say this is this point, arbitrary point here, and now with that new point I will be able to connect this point, which is my maximum amount of time I can spend enjoying leisure time. Yeah, so that's my budget constraint too. Right, so the reason it just dropped here, the consumption dropped, is that because now I have less income after the taxation, I will be able to enjoy less consumption. So there is a decrease down to this point in my affordability. In terms of time, I haven't made any decision. So if I worked less, given my income tax or given my income declining, I may work more hours, which means then less leisure. So I will be moving to the left of this 24-hour point, yeah, because that's the maximum I can get. So the less leisure I do, then more labor time I will be spending, and this along this axis the points then start increasing, yeah, so my consumption increases. All right, so let's go to the next question. Question 4b. So we will continue with our labor leisure trade-off. So this is our labor, this is our consumption axis, and let's read our question now. So show how the tax might lead you to work more hours. So our tax rate was 15%, and our original income was £100, let's say, and our after-tax income is £85. So as you can see, the disposable income is lower now. So we have to show three scenarios: more work hours, fewer hours, or the same hours as before, even after the tax is applied on our income. So when tax is applied on our income, what happens is that our hourly wage decreases. So basically what happens is this: in this diagram we have a point where we can have the maximum leisure time in a given day, so that's 24 hours. Yeah. So that's the 24 hours of leisure time. Then obviously let's put this zero leisure time. So I will use another color here. Also, this is not zero actually. So this is basically this dotted line is a leisure time, which increases, yeah, as we work less. Now I'll put in a different color a zero value here for a labor time. So this is labor time, the work time. Yeah. So then it will go this way. So essentially what it means is that the more you sort of have as a leisure time, the less there will be left for labor time. So 24 hours here. Now what it means is that if you work all 24 hours in a day, then you will have some sort of maximum wage here. Yeah, right there. So this is the maximum sort of wage based consumption. Yeah, so it's the total consumption given the maximum available time that you worked, while this is the maximum leisure time given the available time in a day. So there is this sort of trade-off between these two cases. Yeah, so leisure and leisure. Yeah, the more you work, the less leisure, the more leisure you have, less time for work. Yeah. All right, so that's this sort of trade-off here being considered. And as you remember, our so if in case of, let's say for the first case, yeah, budget constraint, budget constraint under the first case will be this. So this is our original budget constraint. Drawing is very hard. Okay. Let's say that's the one. And after the imposition of the tax, we have low income, that's £85, and if you divide it by available hours, that will be lower wage rate as well. So we will essentially then have less time for work, and obviously consumption will also decrease. So that leads to this point. Now let me draw another arbitrary point, another line connecting these two arbitrary points. So let's keep red. Yeah, so I just wanted to be consistent here, and I couldn't. It will be difficult to draw using the second shape, apparently using the shapes. So I'll just decided to draw that way, and this is our consumption 0, which was on the £100 income, and this is a consumption 1 on the utilizing the all available £85 income, for example. These are just examples. You can pick any value. I like working with hundreds because they are, easily divided, multiplied, and easy figures. Basically, I like working with zeros, especially when you deal with percentages and fractions. So this point here is the maximum amount of leisure, whether your wages change or not changing. But this point is when the consumption that you can enjoy after the taxation, and this is before the taxation kicked in. Yeah. Okay, so black line is the budget constraint 1. The red line is the budget constraint number 2. Now we need to demonstrate now our behavior given that taxation leads to working more hours. Now we need to consider two cases here before we move on. There is substitution effect, and that's the first one. The second one is the income effect. When, let's say, wage decreases. Yeah, so let's say this is income decreasing leads to wage decrease. So wage decreasing, what is our actions, or what is our behavior? If substitution effect dominates, there is a different action or behavior compared to when the income effect is dominating. Now, if wage decreases, notice this. Let me just give you a bit of background here. The leisure will be in hours, in consumption will be in pounds. So the price of leisure is basically lost income, isn't it? And the more leisure time you take, less consumption you will have as a result, right? So it's in terms of foregone consumption, yeah, it's the opportunity cost is its price. So price of leisure is the opportunity cost, that is the lost income and lost consumption. So when the wages decrease, leisure's price decreases as well as a result, because the hourly rate is now decreasing. So the lost leisure is not expensive anymore. Yeah, so leisure becomes less expensive. Its big price decreased as a result. So you will be buying more leisure probably, usually, whenever there is a substitution effect. Yeah, so whenever there is a substitution effect taking hold here. However, there could also be an income effect, which means that decrease in wages cause income to fall as a result. Yeah, so in this is the case here. Yeah, so as well, so income fall, and you will then demand less leisure. That's another possibility, and as a result, hours of work increases. Yeah, you try to work harder and more. So given these two effects, the overall effect really is ambiguous. It's not clear to us, but we can analyze them, this overall effect, under three scenarios: more hours, fewer hours, and maybe the same hours of work. So these are the three scenarios we're looking at, and we'll look at the first one now. The first one says, let me just choose another color here. Let's assume that we are currently right here with some sort of L0 amount of labor and some consumption. Oh, it looks like I assigned consumption 0 to this maximum point. So let's put consumption 0, but with a prime. Yeah, so consumption 0 with a prime for this first case. So this is our optimal sort of hours of, let's say, leisure and wage in pounds or in another currency. So that's going to give us our indifference curve 0, let's say. Now, after the wage decreased or income decreased, we will be operating along the red budget constraint, and especially if it leads to more work time, then there will be less leisure time. So we'll be moving along the x-axis to the left, yeah, this way, and along the y-axis upwards, yeah, upwards, because less leisure time means more work, or more work means less leisure time. So more income means higher leisure, higher consumption. So the next point, that or optimal point moving to, will be somewhere here. Let's say it can be anywhere basically, but it has to be to the left now, because we're looking at more hours of work. So we expect that if we work more hours, then we will have less leisure. Yeah, so we'll be moving backwards in this, and what we call this leisure line. We are, I mean, let me just put this down this way, not to confuse you. Let's put everything on this line here. Yeah, so that leads us to this point here. So it's a less leisure time now, but obviously more consumption time as a result. So let's say this is slightly higher than before. It can be lower than before, but the idea here is that if you work more hours, then obviously your leisure declines. Yeah, so, or at least it will keep us at the C prime 0. Yeah, at least on the original, at the original point, let's say. So this is now C1 prime, yeah, C1 prime, this point, whatever the point here is, let's say, is a higher point or lower point, whatever it is. Yeah, so we'll be moving to this optimal point, optimal bundle point. So that's gonna be this. Now the reason this happened is that if income effect is dominating substitution effect, then we will have less leisure. So this is the exact case here. So under the first scenario here, income effect dominates substitution effect. The idea here is that we would expect the substitution effect to be more stronger, given the lower wages, people might feel like, okay, I don't want to work now because it's, it's better. I have some more leisure. It's cheaper to do so. But because we are asked to analyze under more hours, what happens? Yeah, uh, obviously then our the indifference curve moves to the left, and we'll have less leisure. So this can only happen if income effect. Yeah, if the income effect dominates the substitution effect. Yeah, so that's the first case here. So the second case, for the second case, I need more space here. Now, what if we work less hours now, less hours of work? Now, what happens is that if our wage rate decreases, which is the case now, our income decreased, we will prefer substituting more work time with more leisure time. Yeah, so that's natural as well. And let's say we were originally operating right here. I'm moving the points to this point. I could have started at the lower point like in that case, but just so that I have more space here. So this is our original, let's say, budget constraint and optimal point here. Now, with more time or with less time for work separated, we will be having more leisure. So this is our original leisure time. Now, because we're working less now, we will be moving now along the leisure line to the right of this point. So we're spending more time as in our leisure environment, let's say. Yeah, so it's basically in a given day you have either you basically have 24 hours which you can spend for working or having a rest, let's say, yeah, or enjoying your time. So we will now be having this more of that, and let's say we move to this point in terms of leisure, and this will be our new line here. So this is basically case where substitution effect is dominating the income effect. Yeah, income effect would be that the substitution, I should start with the substitution effect actually. If our substitution effect is stronger, in that case we prefer, basically given the cost of leisure is lower because wages declined now, let's say our income is now 85, yeah, so that's declined than the reduction from the £100 before. We may want to substitute some of our work hours for leisure instead, yeah. But then, of course, there is an income effect as well. In other words, we are feeling poorer. We could work harder and more hours to maintain our original income. But because there is a dominating substitution effect, we eventually settle at this point here, at this red point. From this point to this point, yeah, we just move to this point. So this is the sort of theoretical conceptual explanation to the case of working less hours. Yeah, in this case, substitution effect is dominating the income effect. In other words, it has a greater impact, yeah, on our behavior than income effect. Okay, so that's that, and let me just draw this because I think below I have some drawing from before. I'll leave it there, and we'll look at the second case here. Second case says the same, yeah. So we don't change work hours, yeah, after the income tax is imposed. So let's draw our labor consumption line, and this is our original budget constraint 1, and our second budget constraint will look like this here. So it's exactly the same as before, but this is just budget constraint 2. Right, so what happens is that we had this original point, if you remember, this I0 from before, so that's exactly the same thing as before here, and our behavior didn't change. In other words, we didn't actually take extra leisure time or reduce or increase our leisure time, which means we worked exactly the same hours, yeah, as before. So that's L0 remaining at the same spot in this case, yeah. So this is our C0 prime, And notice this, because we didn't change anything, we simply moved to this point from this point, yeah, in terms of our preferences. I1 now, indifference curve 1. So our optimal point is this point now. And this can happen, obviously this reduces our consumption possibilities. So we are still affording less. I mean, as a result of reduction of income, we're still working in the same hours. So our consumption basically declined by 15% as a result, because hours aren't changing. So that 15% increase in taxation or reduction in income will lead to reduction in consumption by 15% as well. So that's a 15% decline. However, our leisure time didn't change, work time didn't change here, right? So the only time this could happen is when substitution effect exactly equals the income effect, or the effects basically cancel each other out. Yeah, there is no dominant effect here. As a result, we keep working. We basically do not change our original behavior, initial behavior. So we will be working exactly the same hours and having exactly the same labor time as before. So that's the explanation, and that's the solution basically to this question. Let's now consider the next question. So in this question, we have Mark and Nathalie both buy only two goods, so food and wine. Consider what happens to their purchasing behavior when the price of food falls. So let's describe this in a graph. So let's say we have food on the x-axis and wine on the y-axis, and we are looking at the case where food price falls. So let's start with the question A. So this is A, actually. This is A, not C. So it is observed that if the price of food falls, then Mark, so in this case we're looking at a case for Mark, buys more food and more wine. So more food and more wine. So explain why this happens. Now, when your income increases and you buy more of whatever you are consuming, then these things are normal goods usually. Yeah? So with income increasing, we demand more of this. So it looks like for Mark, food and wine are normal goods. So let's derive this graph in the graph. So we have original budget constraint with food 0, and let's say this is no, let me just get rid of this. Maybe just leave them as they are. Yeah, so because I want to preserve this F0 and W0s for initial optimal bundle points. So let's say initial optimal bundle is here. So initially this was what Mark was buying. So this is an arbitrary point, so you should be able to choose that without any trouble, yeah, in your assessments. So these are the original optimal bundles, and I will not draw the indifference curve right now, but after I draw the next budget line, and that is after the price of food falls. So if the price of food falls, then quantity of food we consume, or Mark consumes in this case, will be higher. Yeah, so let's put so this is the quantity of food Mark would consume under the original case, but it will now increase, let's say, to this point. Yeah, so I just need to now connect this point and this point. Now nothing happened to wine price, so there's no sort of effect on our wine consumption. So at this point, so this will be, that is the, maybe not the right one. Let's say we have this. Yeah, that's better. So this is our new budget constraint now, and this is our BC2. The blue line was our BC1, budget constraint 1. Now it says, now with the price of food falling, Mark buys more food and more wine. So it looks like it's somewhere here. The new optimal point now is somewhere here along the new budget constraint. So it will give Mark a higher food consumption to F1 and higher wine consumption in W1. Yeah, on the y-axis here it's W1. So that's the new wine quantities of wine as optimal quantity. Yeah? Now let's then explain how this might happen. In other words, why there is sort of outward movement from this point to this point. Yeah. So we just need to draw a budget constraint now. Let's put it this way. This is our, okay, that's not what I want. That's not the color I want. Let's put this thinner. And this is our original indifference curve, I0. Now what happens is that with the food price lowering or the reducing, there is a substitution effect. Essentially, Mark tries to buy more food related to wine initially. Yeah? So there is substitution effect. So we will have a movement along the I0 curve, substituting some wine away with let's say with food, yeah, because food is cheaper now. However, at the same time, what we call this, Mark will have now higher real income. His income has a higher purchasing power now because now there is spare cash. Yeah, so instead of buying more food now, he might actually buy more of wine as well a little bit. Yeah, so with the substitution effect, let's say there is this sort of increase in the food consumption to this point. Yeah, so this is the initial point here, but in fact Mark will never be operating at this point. Actually, this is just our explanation of excuse me, our explanation of movement from the two original points. Yeah, so let me just name them. This is original point A, and this is the next point B. So the idea here is let's say let's call it C here, so that we have sort of intermediate points. Oh, what am I doing here? So this is, yeah, this is C here, and let's say Mark moves here point as a substitution effect taking hold here. Mark's movement will be of the optimal quantities will be from A to, let's say, B. This is point B here, so point B here. However, Mark doesn't stop here because he's got a higher real income. Now what happens is that now he'll be able to operate at a higher budget constraint. Yeah, so his optimal point now moves from point B to point C now, so that's gonna give him higher utility. Yeah, so that's I1 here. Now movement from A to B, as you can see, basically is a substitution effect. So, yeah, so this is due to the substitution effect, so we just describe it as a movement along the I0. He's gonna get exactly the same util. Yeah, let's say 50, but it can be any number, so this is arbitrary. Don't confuse this please with other things. But because he's got now more real income, his real income now is affording him more quantities of both goods, he's gonna move to point C. So movement from B to C now is basically called income effect. Yeah, so movement from A to B is due to substitution effect. B to C now is due to income effect. So in other words, if I were to draw a new budget constraint here that's tangent to B, point B, it would look like this, parallel to this one here, yeah, to this one. So it's hypothetical case here, but as I said earlier, Mark will never be at B. He's just we're just using these sort of assumptions to demonstrate that there is a substitution effect and an income effect. So as you can see, because of that movement from B to C, we have a higher sort of overall movement to point F1. Yeah, and so overall food consumption increases. So the food increase in food consumption due to income effect is higher than the substitution effect, and at the same time there is more consumption of wine. Yeah, more consumption of wine. So this together, in other words, the increase in both wine and food consumption is due to the income effect outweighing the substitution effect in this case. Yeah, if substitution effect outweighs the income effect, it would be the case of only food increasing while wine decreasing. Yeah, so in this case both are increasing. That's because income effect is taking hold in this case, or dominating the substitution effect. It is observed that if the price of food falls, Nathalie, Mark's friend, buys more wine, but less food. Interesting. Somewhere here she's consuming that much of optimal bundle food and wine, yeah, W0 and F0, and this is her optimal point. Now if the food price decreases or falls, what happens is that that will be a new budget constraint with a new new point for food consumption when all the income is spent on food. And with this fall of the price of food, Natalie will, interestingly, will consume more wine, not food. Yeah, so that's interesting. So we will be ultimately somewhere here. So she will be there, I should say. So this is her new optimal point. At this point, there will be more wine, but less food. Yeah, because if you see this, so this is our Natalie's new F1. So that's the quantity of food, and this is quantity of wine. So increase in wine consumption, but decrease in food consumption. This is interesting. If your real income increases, we tend to usually consume less of inferior goods. Yeah. So it turns out for Nathalie, food is an inferior good, while wine is a normal good, because with fall in the price of food, more of both of these items can be bought. But it turns out Natalie prefers buying more wine than food, or in other words, more wine and less food than the original points. Yeah, this is I0, and she was consuming right there. But notice now, she would be, with the fall in the price of food, will be substituting away some of the wine for food, and maybe it's gonna be somewhere in, so this was A at point B here, there. Yeah, and however, because in this case Nathalie's real income increased, she would certainly will be shifting to the higher indifference curve, and in this case it's a higher budget constraint. In this case it's this blue line, yeah, budget constraint 2 here, while this is budget constraint 1. This whole line here is budget constraint 1. Yeah, so after the initial substitution effect, she will be basically having more sort of income. Yeah, so that allows her to move to a higher budget constraint. Yeah, that implies then she can choose any point along this curve, and apparently she decides to choose this point. That's because she prefers buying more wine than originally she bought, and then less food than originally bought. So because food is inferior good for her. So inferior good for her. Yeah, so that's gonna take us right there as a result. So this is again arbitrary. It could be any point here, not here, because that point will give us more food. So it has to be point to the left. Yeah, it should result with the point to the left of the F0 original point. So I just chose this arbitrary point here. This is I1 here. Yeah, so this is the new optimal point here, with now, as you can see, less food but more wine. Now going back to our discussion of the mechanism here, it is possible now, if Nathalie's substitution effect takes her to this point B, we can draw a parallel line to the new budget. And initially she was there, but now it's right there, and at this point we can choose a hypothetical parallel line, and to jump from this yellow line to the blue line, we just need to have an income effect. Yeah, so that income effect is going to be going to leftwards. Apparently takes the optimal point to the left of point B, because for Nathalie food is inferior good. Yeah, so that's going to be a movement to this point right here, with higher wine consumption and less food consumption. Another important point here that I need to mention is that the lowering of the food price reduced essentially demand for food. Yeah, so notice that with this, oops, what did I choose? Oh, okay, one moment. So with the reduction in the, oops, let me just go back again. Right, so with the movement to this point, from this point, we have a lower, essentially a lower amount of food consumption and higher amount of wine. So low prices inducing a low demand means food is a given good. So given good in this case. That is for Nathalie, food is a given good, while wine appears to be normal good because, as you can see, there is the sort of higher income, or income effect is higher in this case, so that increases the wine consumption. Yeah, so while it reduces the food consumption in this case. And another way of looking at it is that if the reduction, if the increase, or let me put it this way: if the reduction in the consumption of food due to the income effect is larger than the increase in the consumption of food due to substitution effect, we have a case of given good. Yeah, one way of looking at it is also whether the demand for food increases or decreases when the price changes. So let me just show you in a demand diagram. So this is our quantities of food and price of food. Now, as you can see, as the price goes up, quantity of food increases. Yeah, that demanded. So this is our upward sloping demand. Demand is usually downward sloping, isn't it? So let me just put it here. So this is demand, and this is also demand. Yeah, and if the price goes up, we would expect the quantity to decline as well. But with the given goods, the demand curve is actually upward sloping. Yeah, so hopefully you remember that from the lectures. So so price 0, price 1. If this is the food price from this case here, and the food price goes up to this, food price goes down to this point, I should say. This is P0 and this is P1. So the food price goes down, the quantity demanded of food is declining. Yeah, so this is a characteristic of a given good in this case. Yeah, so we just conclude that for Nathalie, food is a given good. So assume you are deciding how to allocate time between work and leisure. So we're going back to the work-leisure trade-off. Suppose the wage increases. Is it possible that the person's consumption would fall? Very interesting. Well, it could be. Notice that if you to apply this to sort of relate this to real world is possible when, let's say, your wage increases, you're earning higher wage now, you could actually decide to go to have more leisure time. Yeah, instead of working more or working the exact hours, now you may say, okay, I have a higher income, so I prefer working less. Yeah, that's a possibility. That's relating that to the that's an example to the real life. Now, in theory, this is what happens. So let's say this is our budget constraint 1. Let's say we were somewhere, let's say here, and originally this would be our leisure 0 quantity and consumption 0 quantity. And what's next here? So it says, suppose the wage increase. So when wage increases, our consumption possibilities increase. So I'll put this point here. So that would be our new point when we work all our available time and take 0 leisure time. But our leisure point remains the same. So assuming that we have, if we just don't work at all, then we just use up all the available leisure time. So this would be the maximum leisure time. The only thing that changes would be now the consumption point here, because with higher income we will be able to afford more consumption here. So now let's connect these two. So hopefully I will be able to do that properly. Oops, almost there. Yeah, almost there. Right, so now the question says, is it possible that the person's consumption would fall? So consumption would fall means, so if this was our original consumption point, we would usually be here. Optimal point would usually be there. Let's say that could be anywhere basically to the right of point L0. Yeah, that gives us higher leisure time. So I just choose this for the example. Yeah, so let's say this is our new leisure point and less consumption now, consumption 1. So this is an interesting point, isn't it? When you can consume more, you are actually taking more leisure time and working less time. Yeah, when you are able to actually consume more. Now the only time this can happen is that leisure is strongly preferred here, yeah? Exceptionally highly valued by this person compared to consumption. Now this can also happen I mean when we are able to consume more but we don't due to income effect, we consume less, is when consumption is inferior, yeah, for that person, let's say for us. So consumption in this case could be an inferior good, yeah. So that's because an increase in the substitution effect is offset by a negative income effect here, basically highly, yeah. So if we were looking at this as an indifference curve, I0 as the original point, when our what we call this wage increases, we usually substitute away some of the leisure time with more work so that we can consume more. Let's say we moved somewhere here. This is our point B, hypothetical point B. But we have an income effect, so we have higher income, we can afford more leisure, and consumption could be an inferior good. So then we have a sort of an income effect here, which is negative, which moves us from point A to B and then to C here. This is point C. This would be our new indifference curve 1. So with a higher leisure time, because we value leisure exceptionally well, while consumption is our inferior good, yeah.